Hello guys, welcome to my YouTube channel. So in this video, I'm going to show you how to create a traffic manager on Azure and how to configure this Azure traffic manager. So what exactly is traffic manager? Based on Azure's definition, traffic manager is a DNS-based load balancer. So for example, here I have an app service running on Azure, which provides the web service. So for example, if I click on this URL, which is https://australiaeast-web01.azurewebsites.net. So this URL actually will bring me to this simple web page, a web page on Azure App Service in Australia East. And I have another EC2 instance running on AWS in London. So this EC2 instance also has a public DNS name or a domain name and an IPv4 public IP address. So I've already installed Nginx and started up the service on this EC2 instance. So this public DNS URL will bring us to its web service. So I've already got this here. So if I refresh on this URL, it actually brings me to this web page, which is a web page on AWS EC2 instance in London. So the app service running on Azure actually is running in Australia East. So now I have two app services running in different regions. One is in Australia East, another one is in London. So what I want to achieve is that so for all the clients from London or closer to London, we should redirect them to this EC2 instance. For those clients running in Australia or close to Australia, for example, in Asia or in Singapore or in somewhere around Asia Pacific. So we should service them using this app service. That's the first thing I want to achieve. And the second thing is that so for example, if this app service goes down or I need to put it into maintenance mode or have an outage, those clients from Australia East or from Asia Pacific, they should still be able to access the web service via this EC2 instance. So that's a failover or high availability. So how can we achieve this? Well, Traffic Manager comes in rescue. The next question is how can we create a Traffic Manager? Well, we just need to go to Azure portal, which I've already logged in. So here we can go to the portal menu on the left-hand side, and we click on it and select all services. From all services from here, we can type in Traffic Manager, and that fills out the Traffic Manager profiles. Recently, Azure has changed their portal. So in the past, there should be a star or asterisk somewhere here. Then you can click on that star, and then that will put this service into your favorite blade. But now they canceled that star, and what you need to do is just hover and stop your cursors on top of the services, and then a new menu or new window will pop out, and from there you can find out that star, and then you click on that star. That will put this service into your favorites blade, which is something I've already done here. So you can either click on this shortcut here or click on this blade. So we just click on this, and then here now we are on the Traffic Manager Profiles Management page. So from here we can create a Traffic Manager profile. Okay, let's do it. So the first thing we need to do is just provide the common parameters like the name and the subscription and resource group and that kind of things. So basically you need to provide those information for all of the Azure resources. So first of all, we need to provide a name to it. So this name needs to be global unique under the Traffic Manager.net subdomain. So for example, if I go something like azure.traffic.manager.net, so that shouldn't let me do it because this resource name Azure or a part of the name is a trademark or a reserved word. Or of course that Microsoft doesn't allow you to use Azure. Let's try something new. For example, we try test. So I guess there must be someone using it. So yeah, domain name test.trafficmanager.net already exists. So please choose a different DNS prefix. Okay, so fair enough. So what we can name it, we can name it ACM account master dash TM traffic manager dash demo. Hopefully no one is using this. All right, cool. That gives me a green tick, which means I can have it. Now, the second thing is the routing method. So actually, traffic manager has 1, 2, 3, 4, 5, 6 way of routing client traffic. So in this demonstration, we will choose performance, which means that the traffic manager will traffic the client's request to a backend endpoint with lowest delay to that client. Okay, so we choose the routing method, and the next thing is the subscription. Of course, that's you need to have a subscription to run any Azure service. So I have only one, so I choose that one. So this resource group and this resource group location. So it's worth to mention that the traffic manager actually is a global service. So no matter which resource group or which resource group location you choose, your traffic manager is globally available. But Azure still needs a resource group to put all those metadata information in. For example, if I choose this rg-tm, so which automatically grays out the resource group location because this rg-tm resource group is actually located in the US, central US. You cannot choose the location for traffic manager because it is global available. But however, you have to choose a resource group for it, which belongs whatever location you create this resource group. Okay, so we have all the parameters configured. Now we can create this traffic manager profile. So, okay, the traffic manager profile has been created. It took about 1 or 2 minutes, so not too bad. So now if we refresh on these traffic manager profiles, it's still not showing us. Sometimes it's just the GUI problem. If we just go to the traffic manager profiles again, it might just, so now it shows us the ACM-TM-demo traffic manager profiles. Now, if we just drill down to this profile, we can see all the configuration for this traffic manager. Now, so on the overview, we can see that the resource group and the status enabled and subscription, that sort of all sorts of normal information. And now we can see its DNS name. Obviously, that's something we choose. Okay, so right now the routing method is performance. So actually, we can go to the configuration to change the routing method if we want. So we can change it to weighted, priority, geographic, multi-value, or subnet. So that's the routing method. So if you change your routing method, that affects the way how traffic manager choose a backend endpoint for a specific client. So we have the endpoint monitoring setting here and the fast endpoint failover settings. Basically means that the traffic manager is constantly monitoring all the backend endpoints via either the HTTP protocol or HTTPS or TCP protocol. And which port it is using, you can change it to any port you configure. So that depends on what exactly ports your endpoints are listening on. So that's how the traffic manager monitors the backend endpoints. But the fast endpoint failover settings, that determines how often the traffic manager probes the backend endpoints. So here by default is 30 minutes. We can go down to, 30 seconds. We can go down to 10 seconds. So which will be faster to detect the backend endpoints failure. And the probe timeout, so now this gives me an error because we configured the probing interval to 10, so our probe timeout should be less than 10. It shows me that the value must be between 5 and 9. So now we can give it, for example, 6. And then, so the tolerated number of failures, which means that how many failures before the traffic manager declares the endpoint as a failed endpoint. So this by default is 3, so which means after 3 times of unsuccessful probe to a given backend endpoint, then the traffic manager will declare that endpoint as a failed endpoint, and which will take it out of its backend pool. So okay, that's the configuration. So if we save it, that will apply the change we have just made. So that's the first important part of our configuration, which is the routing method and the failover settings. So the second important part of the configuration is the endpoints. Obviously, without endpoints, Traffic Manager just can't do nothing, right? So Traffic Manager itself doesn't provide any service except load balancing. So for example, it doesn't provide any web service, it doesn't provide any SSH service, it doesn't provide any database service. So the real service is being provided by the backend endpoints. So now what we need to do is to add those two web services to the traffic manager as endpoints. So first, let's add the Azure App Service. Here you can choose what kind of endpoint you are adding. So it supports 3 types of endpoints: Azure endpoints. Obviously, that's a service from Azure or external endpoints. So for the AWS EC2 instance, obviously we will need to choose this external endpoints. And the name, so you just need to give the endpoint a name and the FQDN or full qualified domain name of that endpoint. First of all, let's add the app service, which is an Azure endpoint. So we choose the Azure endpoints, give it a name. So we can call it app service on Azure. And so the target resource type, so you automatically list the supported Azure resource type. So cloud service, app service slots, and public IP address. So just to point out that if you want to configure any Azure service using public IP address, so this public IP address actually needs to have a DNS label, otherwise Traffic Manager will not accept it. So the first service we are going to configure is an app service. Now we need to choose the app service from here, so which is our Australia East-Web 01. So we put that in and we hit OK. So this endpoint is being configured. Just give it some time, it will just pop it out here. And the location has been automatically being configured to Australia East because Azure knows it is running in Australia East. However, for the AWS EC2 instance, because it is an external service, so Azure has no way to know where this service is located. So we will need to configure the location manually. So we will see in a minute. We're gonna add the EC2 instance here. So obviously we will need to add it as an external endpoint. So just give it a name again. So we can call it AWS EC2. So we just call it AWS-EC2. Here, we cannot actually choose the service because it is not part of Azure, right? So we will need to put in the FQDN name or IP address. So here, if we want to configure an endpoint using IP address, all the endpoints under that Traffic Manager profile have to be configured using IP address. Otherwise, we will need to configure it using the domain name, so which we can find out from the AWS console, which is the public DNS name here. So we copy it here, and then we just go and paste it in here into the Traffic Manager's endpoint configuration. And now, so that's the final part. So the location, you actually just manually choose it. So even it is running in London, you can actually configure it as, for example, East Asia or Central US, because Azure has no way to know it. However, you just feel guilty just to to cheat the computers. So we'll just be honest. If my geography knowledge is correct, London should be in West Europe, right? Or if I am wrong, just let me know. And then if I'm correct, so we just go and click OK, and then added this endpoint into this Traffic Manager. Okay, so now we have 2 endpoints. So we should be able to verify this Traffic Manager. One is running in Australia East, another one is running in West Europe. Just to point out that this AWS EC2 instance is still being checking. So we'll just probably give it a minute and just let it finish this checking endpoint status. So after 1 or 2 minutes wait, this endpoint has passed the initial checking. So now we should be able to verify it from the clients. So now here I have two clients. One is running in France Central, which is part of the Europe, right? I don't know what exactly the location it is, but should be pretty close to London. Another one is an EC2 instance running in AWS Sydney data center, so which should be very close to Azure's Australia East data center. So sorry, there is another client which is running in East Asia. Again, if my geography knowledge is correct, if I was learning in high school, so this client should be closer to Australia East, right? So okay, let's test it out. So what we can do is that we can use curl and then paste in the traffic manager's URL. Okay, so it's a web page on Azure App Service in Australia East. All right, we've been redirected to the app service running on Azure in Australia East. That's great. So that's for the East Asia. How about the client running in France Central? All right, so let's do the same thing again. Great. So a web page on AWS EC2 instance in London. So basically the traffic manager has brought us to the EC2 instance running in London. That's great. So how about the client in Australia? The answer should be very obvious, but let's test it out. So basically we got a response from the app service running on Azure in Australia East. So that's great. So basically we've achieved the first requirement that I wanted to have, which is just to serve the clients as close as possible, right? So how about the second requirement? So what will happen if the EC2 instance running on AWS in London fails or its web service stops? So the clients from France Central should still be able to connect to the other web service, which is the app service running on Azure in Australia East, right? So okay, so I've already logged into this EC2 instance, so let's just verify it is the instance running in London. So if we check the IP address, which is the private IP address of this instance, the last 3 digits is 156. We just go and check it out from the AWS console. So yes, so the last 3 digits of the IP address of this EC2 instance is 156. That's the correct console to the EC2 instance. So if we just stop this Nginx service, let's check its status. It has already been killed. So if we just go back to the France Central instance, so if we just go to the curl again, so okay, so we've tried multiple times, and now it finally brings us to the web page on Azure App Service in Australia East. So why it worked in this way? That's because this client has DNS cache, right? So generally, if a client resolves a DNS name from the DNS server, it will cache its IP address in its local cache, right? The DNS cache has a TTL time, which is time to leave. So the only time it will just to go and resolve the IP address again is when this cache times out or expires. So obviously, this DNS cache on this Linux client took about 2 minutes to expire. So after the cached traffic manager DNS name expired, it went to the traffic manager to try to find out the new IP address. Which then gives the traffic manager a chance just to redirect it to the other web service, which is the app service running on Azure. Basically, that's how traffic manager works, because it doesn't like the load balancer or application gateway. As soon as the client resolves the endpoint's IP address, then the client will communicate with the endpoint directly without going through the traffic manager. That's the reason why traffic manager has no way to control the clients unless the clients come to the traffic manager to resolve the DNS name again. And if we just go and check the other 2 clients The first one is the EC2 instance running in Sydney. It should still be okay to access the traffic manager. That's because the app service in Australia East is still up and running. So right, this does not affect the clients close to Australia East at all. So for example, this one, if we just do a curl again, so you still be able to access that traffic manager, which is accessing the app service running in Australia East. So that's the end of this demonstration. So hopefully you guys know how to create a traffic manager and how to configure it now. If you enjoyed this video, just please subscribe. We'll have more videos coming soon. Alright, see you next time.